Alright, rolling. Alright, so as of now it adds 50 random numbers to a linked list. Now what we're gonna want to do is actually sort the linked list. So, because it adds random 50 numbers and they're not in order, so now we're gonna have to make sure the linked list gets sorted for each new element added. So we're gonna manually instead insert and let's do a few different numbers. 5, 1, 9. So then, and our goal is to make it so that the linked list ends up being 1, 5, and then 9 instead of 5, 1, 9. So now go to the part where it inserts to the linked list, and I've actually made a modification to this part now where it checks whether entry is compared to first value. Well, let's change things up here. Right, element, new element is equals to the new element structure pointer being created, and then so this first scenario is for when size is equal to 0, so that's the first element being added. And then if we're adding more elements after that, first it's going to compare entry, if entry is less than first value, which is the value inside the very first linked list element, then what's going to happen now is first prev is going to equal to the new element being added, and then new element value is going to equal to entry, and yeah, let's move that one up, and then new element next is equal to first, and then first is now going to equal to new element, and that's for the scenario. Oh, actually there should be a pointer right here. There. So yeah, that's for the first case scenario where entry is smaller than first value, and so that'll be, we're gonna have to make it descending order so that now it inserts the largest number first, smallest number last. And then, alright, here's the command prompt window. Oh, yeah, I meant previous, first previous. Right, and now a.exe. Right, and now yeah, it puts in an order from smallest to largest, but this is only when you're inserting elements largest to smallest. Now we're also going to have to deal with the other scenario. So else, well, let's change it to less than or equals to. That way it also applies if you add duplicate elements. Yeah. Alright, so now the other scenario is when entry is greater than first value, which in that case we're now going to set current to first, and then we're going to have to make a for loop. And there's a similar for loop already when we're printing the linked list. It looks through every element in the list, so and then it's gonna increment current equals current next, and then prev, well, this variable called prev last, yeah, now we're gonna have to change it to prev current, and then use the replace tool. See right here, and then yeah, now it's prev current. Prev current equals current. And then it's gonna it's gonna compare the current the entry number to the current's value. So if entry is less than current value, and then so then current previous is now going to equal to the new element, while prev current next is going to equal to new element. Alright, so now we're gonna run the program. Oh, now we're gonna have to change it up a little. Alright, so it goes from 9 to 5, and then it's gonna go up to 7, and then yeah, we're gonna want it to have 5, 7, 9. Right, there seems to be something else going on here. Now let's see what happens if, well, since 7 is the third element being added and then it's not being added in here. So let's look back on this. Oh, we're not assigning the new value here. So yeah, let's go ahead and do that. Take this line out of here and then put it right here instead, right before the if and else statements. So yeah, but this isn't how it's supposed to be either, because now it's being added after the 9. So now let's see what happens if we add 2 9s at the beginning. Alright, well, it seems the second 9 isn't being added anywhere. So let's change it to 8 then. Okay, so now it goes 5, 8, 7. So yeah, there's definitely something that went wrong at the part where we were supposed to be adding a new larger element. Because again, let's, change this to 9, 5, 3, 1, 7. And yeah, all of it goes well up until the part where it's supposed to increment upward. So now we're going to try another thing. Change the 7 to a 2. And now it just gets stuck pretty much. Whereas if I put it to 7, right, so we're going to go back into this for loop. Prev current equals current, and then yeah, we're gonna have to move prev current down to right above current equals current next. Right, it gets 1357, but then it stops at 9 for some reason. It's not print, well, which means the 7, the element that has a value of 7, doesn't have a pointer to next, it seems. And yeah, we're gonna have to fix that right now. So new element, and we're also gonna have to create another, integer variable that represents a bool. So let's call it int, and then is last equals to 0, and then if entry is less than current value, then is last equals to 0, and then yeah, and the new element previous equals prev current, and the new element, this, and the new element next equals current. So now if we run, yeah, and now it works. So now we're going to try adding, well, actually we're going to have to do a little more here as well. I'm going to have to add an else. Well, actually it's going to have to come after the for loop. If is last equals to 1, and yeah, so then the last it's going to have to equal 1 right up here, since it is going to become 0 as long as it's not the largest element value. So if last is equals to 1, then current okay. Oh, different idea here. If size, well, actually it still reaches the very last element anyways. If is last is equals to 1, so then current next is gonna now equals to new element. And then yeah, you get new element value equals entry, and this is for if, let's say, we were to add a very large number at the end, let's say 17. Well, there seems to be something wrong with this last part right here. So yeah, current next equals new element. If I is less than size minus 1, alright, so now it works correctly. 1, 3, 5, 7, 9, 17. Alright, now it's a sorted linked list. Right, so now we're going to go ahead and make it add 50 random numbers, because now I think it's going to be able to do all that. There. Right, so it's not able to, it seems. So let's see. We're going to have to, let's say, add another small value after the 17. Well, but then add another even larger value first, and then make it go down to 2. So now our goal is for it to be 1, 2, and yeah, we can add duplicates. 1, 2, 2, 3, 5, 7, 9, 17, 19. Oh, and there was actually an error right here. If last equals to 1, yeah, you should actually use 2 equal signs. And then, yeah, skipping the first, so yeah, we don't need to assign prev current dot next, well, prev current yet. And then, well, alright, so then current equals to first, then yeah, it increments each time. If, and then is last is set to 0. We're also going to make it so that it instantly, if the new element is added, we're going to set I equals to size, so that it instantly breaks out of the for loop. And yeah, for debugging purposes, I'm going to have to print new line at the end of linked list, because we're also going to be printing the linked list every time we add a new element. So yeah, as you saw earlier, we want the elements in this order. Right. And yeah, it does work. See, it goes 1, 2, 2, 3, 5, 7, 9, 17, 19. So now let's go ahead and add 50 random numbers and see how it goes. Oh, wait, we're gonna have to undo the printing linked list every time. And yeah, again, we're gonna go back to just making it print once right here. Alright, maximize command prompt, clear main.c a.exe. Alright, let's make sure every number here's in order. Well, first let's count the numbers here to make sure we have all 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. Alright, so we have all 50 elements, and let's also make sure they're in order. So yeah, 0, 2, yeah, they're all in order so far. Alright, so yeah, now we've got it so that it every time it adds a new element to the linked list, it automatically sorts the entire linked list in order. So now we're not going to print linked list anymore, and then I'm going to pull up the array list performance. Alright, so here, the array list, and then we have the list of the number of insertions, and then how many milliseconds it takes each time. So as you can see, for the array list, it increases exponentially. You know, twice as many insertions, 4 times as much time, 3 times the insertions, 9 times the time. So now we're going to do the same experiment with the linked list. So now let's add 10,000 random numbers. Okay, 201 milliseconds. And our goal is to make it so that it doesn't increase exponentially, but more linear. Now maybe it's not going to be completely linear either, but if we can get it to be somewhere in the in-between, that's going to be good. So yeah, 201 milliseconds, and then now we try for 20,000. .1139 milliseconds, so it increases by more than exponentially. And yeah, this isn't what we wanted though. We wanted it to increase by, let's say, a factor of 2 to 3, no, anywhere under 4, but instead it increased by a factor of 5 to 6. So now we're going to try 30,000 random numbers. Let's see if our results change at all as we continue to increase. 4,265. So yeah, this isn't looking good at all. This is much worse than the array list. And yeah, the 40,000 is going to be the last one here, since, or maybe 50,000, but yeah, since we already know, well, 6914. Yeah, 50,000. Well, since this increase isn't as big as the one before, I may actually go on and then do more even beyond 50,000 insertions. But yeah, it is getting pretty slow. 12,848. Well, yeah, it seems to be somewhat randomized. But yeah, so as of this right now, it's actually going to be better to do an array list instead of a linked list, because as of now the linked list is increasing even more than exponential. Yeah. Although there may be ways to optimize our linked list to make it run faster. So first off, here I'm gonna make it go back to doing only 50. since, yeah, we don't need first, last, prev. Well, we don't need last right here. First element, we might still just have it just to be there. Wait, but actually, we already declare first and then after we add the first element, so yeah, we don't need these declarations right here. First, prev current, and current. We don't need first element here either. Yeah, last value. No, it's going to be first value. Well, here, new value, new element value equals entry, and then first value equals to entry, but also we're going to have to declare first, so yeah, first is going to equal to new element. Right? And then here's the thing about our linked list. It's two ways. It has a pointer to the previous and a pointer to the next. So now we're going to change it into a one-way linked list rather than a two-way. So yeah, it's not going to have a pointer to the previous since we don't really use it anyways. So let's delete previous. And let's go into the main and then find every instance of previous. Instead, this is going to be good enough. The next of new element is equals to first, and then first is going to equal to now new element. We don't need any pointers to current previous or new element previous now either. So now let's yep, and then it still works. Right. Maybe now we can get some better results. So yeah, let's try adding 10,000 random numbers. And then we're 174. But yeah, we're gonna have to make it stop printing the linked list. So comment it out. You know, maybe it'll be 150 milliseconds. Well, still 174. Alright, so now 174. And delete the previous results. Now let's try 20,000. So another lesson to be learned here is to try to avoid two-way linked lists whenever possible. Try to stick to one linked list if that's all you really need. 837. Well, and then let's try this next one. Yeah, 837 milliseconds, so that's still not good either. It's beyond exponential. 2314. $5,043. But yeah, let's actually try going all the way up to 100,000. Even though, yeah, I don't have high hopes for it now. Because it does definitely take a long time to add. Even though, at least for the array list, it was gonna have to, every time it adds a new element in between, it has to shift all the other elements further to the right. And so while that has a weakness in it of itself, it seems to be surpassed by the weakness of the linked list, which is using up extra space, and therefore taking a longer time to look between each element. Okay, now we're back, and yeah, gotten the results of doing up to 100,000 insertions, and yeah, it's not looking good. So it's actually increasing at a rate even faster than exponential. Yeah, so, and that's even with us, making some changes to make it not use up as much memory. And so yeah, it's this kind of proves that array list is the better option for when you're doing C programming, since array list does quicker insertions, because the original intention was for array list to actually have slower insertions than linked lists, but still quicker searching. In this case, the array list has quicker insertions too, and it's gonna have even quicker searching, since you could use a binary search tree to quickly search through an array list. But yeah, array list is just better than linked list when it comes to C programming on Windows. And yeah, so anyways, the next part of the series is going to be about a binary search tree. And yeah, until then, see ya.